Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Kropki Stone Tessellation by Michael Lefkowitz, and here are the rules. We have tessellation rules, where we need to fill each cell with a digit from 1 through 9. And I think these squares are also... So we have these sort of like octagon-shaped things, and we have normal squares. So I believe those are all cells. Cells sharing an edge can't have the same digit. So there's nothing about rows and columns, so we don't have to worry about that. But cells sharing an edge cannot have the same digit. So that means this can't be the same digit as this. And these two can't be the same digit. These two can't be the same digit, etc., etc. Each horizontal row and vertical column contains non-repeating consecutive set of digits, like 2, 3, 4, 5, 6 in any order. Interesting. Okay. So that means this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So any row and column, each horizontal row and vertical column contains a non-repeating consecutive set of digits. So it's like a Ren band, essentially. Or like a row of Sudoku, but it's limited, right? This is 3 digits, this is 5 digits, this is 7 digits, etc., etc. But it's sort of like Ren band, sort of like normal Sudoku there. We have Kropki stones, where digits on opposite sides of a white stone, in cells touching the stone, differ by exactly n, where n is a digit on the stone. And we have digits on opposite sides of a black stone, in cells touching the stone, have a 1 to n ratio, where n is a digit on the stone. So, for example, if this were a 2 and this were a 1, this would have... Well, that wouldn't work. If this were a 2 and this were a 4, this would have to be an 8, because the ratio for this digit must be 1 to 2. Sorry. This 2 signifies the ratio that these cells that are neighboring it must have a ratio of. If this were, say, 3 and this were 2, this would have to be 6, right? So, and then for the white stones, you could have this be white stone, say this was a 5. If this were 5, the difference between these two cells must be 5. So it could be like something like 1 and 6, and the difference between these two cells must also be 5. And this actually could be also 6 and 1, because they don't share an edge with each other. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we've done Kropki stones before, and one thing we found out was if there's a black Kropki stone between two pair of digits, if the digits have to be contain some overlap, right? So in the puzzle that we had it with a normal Sudoku, but it was in the middle of the grid. So it was between two cells above it and below it, and two cells to the left and right of it. But two of the cells were sharing a cell with one other cell. And from that, we figured out the black Kropki stone has to always be a 2 in that situation. And the reason why we know that is, say this was a 3 or 4. Those are the only ones that can have a 1 to n ratio with the n without containing a 1, obviously, right? So 2 can be both 4 and 8 and 3 and 6. 3 can only, unfortunately, have 2 and 6 because 1 and 3 contains a 1 and 3 and 9 contains a 3. Okay, so sorry, that doesn't contain 1 or itself. So 3, to be in a 1 to 3 ratio, you can only have 2 and 6 specifically. And to be in a 1 to 4 ratio, you can have 2 and 8. And those are the only sets of digits, right? Well, these cannot share the same digit, right? Because these two are consecutive, are share an edge with both of these. So if this is a pair, these cannot be the same pair. So therefore, the only one with two uniquely different pairs is 2. So this is a 2, which means this is 3, 4, 6, 8 surrounding it. This cannot have a difference of 8 because we only have 7 digits here, and they have to form essentially a Renban-like structure. So it needs to be 1 through 7, 2 through 8, or 3 through 9. Similarly, actually, I don't think this can ever be 3, 4, and 8. If this is 4 and 8, that means this Renban is 5 length in length. How can that be? It can't be with 4 and 8. 2, 3, 4, 5, 6 is the most that you can have for 6. So this actually has to be a 3, 6 pair, which leaves the remaining digits in the row as 4 and 5. This 3, 6 pair eliminates 3 and 6 in the rest of this. Cannot be the same in the cells that it's touching. So this is a 4, 8 pair then. 8 again cannot be here because, well, 8 cannot be here because the difference between two digits that are 8 apart is 1 and 9, and that can't be on a 7 length Renban. So this must be 4, and this has to be 8. The difference of 4 here, so this is 2, 4, and 8 here along this column. That's a 7 length Renban, which means the remaining digits must... Okay, so the difference between 4 and 2 must have a 6, right? The 4 away from 2 is only 6. That means the remaining digits are 3, 5, and 7 to form a Renban in this column. This is 8. It must be with 5, 6, 7, 8, or 9, right? It's a 3-length Renban. Can't have 8. It has to be either 5, 6, 7... can't be 5, 6, 7. It's 6, 7, 8, or it's 7, 8, 9. Okay. So then this is 6, 7, or 9. And 7's guaranteed as one of these two digits. Okay, we have a 4, 5 here, a 4, 5 here. Um... 3 and 6. This difference is 4 apart. Okay. This difference is 4 apart. So we have... These must be the digits 1 through 8 or 2 through 9. These are the digits 1 through 9. Oh, there has to be a 4 difference across here, too. And then across here. Right. So it also has to be here and here is a difference of 4. So 3 and 6 has a difference of 4 with its 7 and 2, right? 3 can only be 4 away from 7. 6 can only be 4 away from 2. So this is a 2-7 pair. That means this is a 2-7 pair, which eliminates 2 and 7 in the rest of this row. That means it has to be what? 1, 3, 4, 5, 8, 9. Okay. Obviously, 9 cannot be in the white Kropki stone. You can't have 8 here because it must be next to 1 and 9. So 1 away works. Does 5 away work? 5 does not work because 2 would have to be next to a 7, and we're guaranteed this is a 2-7 pair. So this cannot be 5 away. 4 away from 2 is 6, and we can't have that. So this can't be 4 away. 3 away from 2 works as long as this is 5. Oh, wait, hold up. Okay, can't be 8 or 9. But the thing is, this is 2 or 7. It doesn't have to be both. So this can't be 8 or 9. It can't be 5 away because 2 or 7 would 2 would have to be next to 7, and 7 would have to be next to 2. Or across from 2, sorry. 4 does work, but only if it's 7, right? So 4 away works if this is 7. Oh, hold up. This difference has to be at most 2. Because if it's more than 2, the problem is that then this can't form a Ren band. So if this difference is 3, you had 1 and 4. 1, 4, 3 doesn't form a good Ren band. So this has to be a 1, which means this can't be 1. This must have then a 2 and a 3 next to it, because those are the only one that forms a Ren band with a 1. This is 2 or 7. If this is 2 and 1, this would have to be 3. Can't be 1, obviously. 1 away from 7 cannot be 6. It would have to be 8. So this is 3 or 8 here. This is a 2-3 pair. Both of these 2-3s see this cell, so this can't be 3. This can't be 2, so this is 8, which makes that 7. That makes this a 2, so none of these can be 8. This 2 is 4 away from 6, so this is 6 here. This 7 is 4 away from 3, so that's 3. This is 6, 7. To form a Ren band, you do not have... Well, okay. It could be 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9. So we have 3, 4, 5, 8, 9 as possibilities. This is also a white Kropki dot. So this difference is 1, this difference is 1. This can't be 4 because of the 4 in the row. Or, sorry, 4 in the neighboring cell. This can never be a difference of 8 or 9 between these cells. So this is 3, 4, or 5. Since one of these is 3, 4, 5, this can never get to 9. So this can't be 9 here, this can't be 9 here. We are guaranteed one of these is a 5, but we don't know which. 4 away from 3 can be 7. 4 away from 5 can be 1 and 9. 4 away from 8 would be 4, so this can't be 8. This is 3 or 5 also. So we have 3, 4, 5 here. 3, 4, or 5. Can this ever be 3? And the answer to that is no. If this is 3, It's not, it's 1 or 0 away from that digit, so this can't be 3. If you have 5, it's 3 away from 2. That works. If you have 7, it's 4 away from 3 or 5 away from 2. So either of those work. And this can't be 7 because the 7 shares an edge with it. So this must be 5, which makes this 2, and it has to be 3 away from that. 3 away from 7 is only 4. So this is 4. This is 3. That makes this a 5, which makes this 3. Because you can't have 2 here in the row or in the column. So this is 2, 3, 5. 5 and 2 are 3 away from each other. 4 and 7 are 3 away from each other. This can't be 5 because of the 5 in the column. 4 away from 5 is 1 or 9. And that's the only 1 or 9 in that row because it's a 7-length Ren band. So it's either 1, 2, 3, 4, 5, 6, 7, or 3, 4, 5, 6, 7, 8, 9. Those are the only possibilities. So the remaining digits are 2, 6, 7, 8 as possibilities. This is 3, 4, 5. One of these is 7. Remaining digits here. This is either 1 through 7 or 2 through 8. So we have 1, 4, 6, 7, 8 as possibilities. This is 3 or 7. Again, this Ren band cannot have a difference of greater than 2 because this is only 3 length in Ren band. So this has to be 1. So this must be 1 with this being 3 and that's 7. So this is 2. This is a difference of 1. This 1 eliminates 1 here, so this is 9. Therefore, this must be a 6, 7, 8 triplet in the rest of this row. This can't be 1 because of the 1 in the column. This can't be 9 because of the 9 in the column. Remaining digits in column, in the middle column here, is 4, 5, 6, 7, 8. This can't be 8 because of the 8 that it shares an edge with. This can't be 7 because of the 7 it shares an edge with. This can't be 5 because of the 5 that shares an edge with. This can't be 4 because of the 4 in the row. This has to be then, what are the remaining digits here? It must be either 3, 4, 5, 6, 7 or 4, 5, 6, 7, 8. So 3, 5, 6, or 8 here as possibilities. This difference between these two must be 1. So it has to be an odd digit. So this can't be 4, 6, or 8. It's 5 or 7. Either this is 5 and 6, or this is 7 and 8. It cannot be 6 and 7 because that would eliminate all possibilities for that cell. So this is guaranteed to have 1 of 6 or 7. This is guaranteed to have 1 of 6 or 7. That eliminates 6 or 7 from the rest of the column. Okay, we are guaranteed a 5 in one of those two cells. Again, this has a difference of 1. This has a difference of 1. Okay, this can never have a difference of 8. It cannot have a difference of 7 because the minimum of these are 3. So this can never be 7 or 8. Could have a difference of 6. It could have a difference of 4 or a difference of 1 here. Can it have a difference of 4? Maybe not. 4, 6 it could be, 3 and 9. 4, 5 and 9. 5 and 9 does work. And then the rest are fine. Okay, let's look at this Kropki stones. 1 is the difference between 2 and 3. 1 is also the difference between 5 and 6 and 7 and 8. So that's satisfied there. 3 is the difference between 2 and 5 and the difference between 4 and 7. 1 is the difference between 2 and 3 and 8 and 7. 4 is the difference between 2, 6, 3, 7, 2, 6, and 5, 9. This is only between these two. Okay. So we are guaranteed a 4 here and a 6 here, but this can't be 6. So 6, one of those 3. 7 for one of those 2. This is 6, 7, and 8. This column has to be a red band. And it has a 2, so there's no 9 involved here. So this becomes a 6, 7 pair here. Because you can't have 2... It's either 1 through 7 or 2 through 8 for that red band. 1 cannot be here because there's no 2 in this column. So 1 can never be here. And this can never be 1 because this red band would not have a 2 either. So this can't be 1. So 4 or 6 is here, which means it's either 3, 9 or 5, 9. 8 and 4 does not work because then the 4s would be consecutive with each other sharing an edge. And 6 doesn't work with 2. 3 doesn't work, doesn't have a 7 here. Again, 4 and 8 doesn't work. 5 cannot be with 9 here. So this must be a guaranteed 9, which means none of these two are 9. So it's 4 and 6 here. This must be 6, 7, or 8. So if this were 4, that wouldn't work. Because if this is 4, this would be at most 5. Oh, that could work. 4, 5, 6. This has to be 5, right? Say it's 3. If it's 4 here, that's 6, and then this would be 7 or 8, and that doesn't form a Renban. If this is 3, did we try? If this is 3, this is 4 at most. There's no 5 in between to form a Renban with it. So this always has to have a 5, right? It can't be 6, 7, 8, because this can't be 6, 7, or 8. So this must be 5, which means these can't be 5. So this is either 5, 6, 7 or 4, 5, 6. So this cannot be 8 here. One of these is an 8. 4, 5, 6 works too. One of these is a 6, but that's not helpful. We are guaranteed a 6 here. We are guaranteed a 6 here. We are guaranteed a 6 here. How many 6s is that? I think that's 4, right? So, yeah, this is fine because of 1, 2, 3, 4, 1 through 9 here. This is fine because 1 through 7 or 2 through 8. We're guaranteed a 6 here. That's interesting. It could be 4, 5, 6, 7, 8, or it's 3, 4, 5, 6, 7. Okay. If this is 4, this has to be a 5, which makes this 4, which makes that 3. So this would be 3, 4, 5, 6, 7. If this is 6, this would be 3, and then this would be 4, and that would be 5, and then this would be 3, 4, 5, 6, 7. So either way, this must be 3, 4, 5, 6, 7. This is specifically a 3 or 5 here. To be 4 or 6 away from 9. This can never be 8. This can never be 8. Where is... We have a 6, 7 pair in this row here. That eliminates 6, 7 in the rest of the row, so this is 8, which means none of these can be 8. This has to be 2 through 8 here to fulfill that, so this can never be 1. We have a 4, 6, 7 triplet, which eliminates 4, 6, and 7 in the rest of the row, so this can't be 4. This is 8, which means this can't be 8. That's 6, which means neither of these can be 6. This becomes a 3, 5 pair. The 6 eliminates 6 here, so this is 7, which makes that 6. The 7 eliminates 7 here, so this is 5 and 6, which is 1 away from each other. This 5 eliminates 5 here, so it's 4. We have a 3, 4, 5 triplet in this column here, which eliminates 3, 4, 5 in the rest of the column. This can't be 4, can't be 6, it must be 7. So this can't be 7. We have a 3, 4, 5 triplet here in this column. So this can't be 3, 4, 5 in the rest of the column. So this is 6, which makes this 7. This 6 eliminates 6 here, so that's 4. This 4 is 4 away from 9, so this must be 5, which makes that 3, which makes this 4, which makes that 5, 4, 3, and this must be a 6. And that's a solution to it. Pretty interesting. It's very similar to Sudoku, but you have to think through things a little bit with the Kropki stones. Pretty cool use of the Kropki stones. We ran into that. I think Michael Lefkowitz introduced that a little bit earlier, and I thought it was pretty limiting. It still is pretty limiting, but you need that restriction here because the tessellation is going to make things a lot more difficult because we are not guaranteed the digits 1 through 9, right? So that was actually pretty interesting use of the major restrictions you have with Kropki stones. And it works very well with the tessellation because tessellation is much more open-ended than, say, a normal Sudoku, I would say. Well, that's not necessarily the case, but Sudokus usually have a lot more rules to limit things. This only had the Kropki stones and the tessellation itself, which is not very many rules to limit things. So, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.